Today we're going to talk about box plots. So of the statistical displays that we are going to be talking about for this unit, I think this is going to be the hardest one to make because it's a little bit different than things that you've seen in the past. You've seen line plots and histograms a lot before. So a box plot uses a number line to show the distribution of a data set by using the median, the quartiles, and the extreme values. So it splits the data into 4 parts. Each part, if it's split into 4, represents 25% of the data. So I want to look at this. When we're splitting it up, right, we have our median value, we have our Q1 and Q3. We've already talked about how to find those. Once you cut it 3 times, it splits into 4 parts. And then you have your upper extreme, which is your highest value, and your lower extreme, which is the lowest value. So when we look at this, it's cut into 4 parts. You've got this first part, which is your lower extreme to your Q1. You've got this second part right here, which is your Q1 to your Q2. You've got this third part right here, which is your median to your Q3. And you've got this last part right here, which is your Q3 to your upper extreme. So they have the same number of data values, but some of them are more spread out than others, okay? But this is going to represent 25% of the data, this is another 25% of the data, this is another 25% of the data, this is another 25% of the data. So, for example, if I cut it off here, anything below that is 25 and 25%, which is 50%. Okay? If I cut it off here, we've got 25, 25, and 25. So anything below that, that's a total of 75% of the data values. Okay? So let's look at this first problem here. A restaurant recently collected data to see how many minutes their guests waited for a table. The data is presented in the box below. Use the plot to answer the following questions. So first, we're just looking at analyzing this box plot, and then we're going to actually start making our own. So first I'm just identifying the different values. The lower extreme is the lowest value. It matches up right here, which is in between 14 and 16, so that is 15. The next values are Q1, which is at 24. This line right here in the middle is our median, which is at 29. The next line, the right side of the box, is our Q3, which is at 33. And then this upper extreme is our highest value, which is at 35. Okay, so if you want to write that here, lower extreme, Q1, median, Q3, upper extreme, it's going to help you with answering some of these questions. So the first thing says, for what range are the data the most clustered? So that's when we're looking at. We've got our range here of our lower extreme to our Q1. We've got our extreme here of our Q1 to our median. We've got our range here, which is our median to our Q3. And then we've got our range here, our Q3 to the upper extreme. So it's saying, for what range is the data the most clustered? Well, let's calculate the distance. From the lower extreme to the Q1, either you can count 1, 2, 3, 4, 5, 6, 7, 8, 9. Or you can subtract. Our Q1 was 24. Minus our lower extreme of 15 is 9. Okay, this range from the Q1 to the median, we can count 1, 2, 3, 4, 5, or we can subtract. Our median was 29, our Q1 was 24, 29 minus 24 is 5. Our next range right here goes from 29, 1, 2, 3, 4 over. Again, we could also subtract. Our Q3 was 33, our median was 29, 33 minus 29 is 4. Last one, we can count 1, 2, or our upper extreme was 35, our Q3 was 33, 35 minus 33 is 2. So, looking at this key word here, it says, for what range is the data the most clustered? When it's clustered, it's close together. So 9, 5, 4, or 2, the smallest range is 2. That's where it's the most clustered. So that range was between your Q3 and your upper extreme. what range is the data the most spread out? So that's going to be the farthest apart, the biggest number, which is 9, this range of 9. That was between your lower extreme and your Q1. Then our IQR, what is the IQR of the data? It's our Q3 minus Q1. So our Q3 was 33 minus our Q1 of 24 gives us an IQR of 9. What percent of people had to wait over 24 minutes? So we look at this one. We just want to look at the different data values here. We've got 25% here, 25% in this range, 25% in this range, 25% in that range. So 24 is right here. So waiting over 24 minutes. So anything greater than 24 minutes. We've got 25%, 25%, 25%, which is a total of 75%. Then it says what percent of people waited less than 29 minutes for a table? Well, our 29 is right here. How many were less than that? That's anything below. So we've got 25% and 25%, which gives us a total of 50%. So for this problem, we are looking at a list that shows the lengths of winning distances in the women's Olympic shot put event. So again, the first thing that we're going to do is we are going to put this in order from least to greatest. So we've got 65, 67, another 67, 68, another 68, another 68, 72, and 74. In order to get the points that we need for the box plot, we first need to start by finding the median. So first off, there's 1, 2, 3, 4, 5, 6, 7, 8. It's an even set, so that tells us there should be 2 numbers in the middle. So I'm crossing off lowest, highest, lowest, highest, lowest, highest. I'm left with these 2 in the middle. You might notice that they're the same number, so that tells you the median is 68. If not, add them together, divide by 2, and you should still get 68 for your median. Now, remember when there's 2 numbers in the middle, we put the line in between. This bottom 68 is included in the bottom half. This top 68 is included in the top half. In our bottom half here, we have 1, 2, 3, 4 values, so there should be 2 numbers in the middle. Crossing off lowest, highest. I'm left with these 2 numbers in the middle. They are the same, so you might realize that the Q1 is just going to be 67. If not, add them together, divide by 2. You get that the Q1 is 67. Same thing for the top half. Cross off lowest, highest. We're left with those 2 numbers in the middle. 68 plus 72 divided by 2 gives you 70 for the Q3. Our lower extreme is the lowest number, which is 65. Our upper extreme is the highest number, which is 74. So we can go ahead and plot these numbers. So 65, 67, 68, 70, and 74. So remember the second and fourth one, that's our Q1 and Q3. Those are the sides of our box, which we connect. This dot in the middle is our median. We're going to draw a line through it. And then we connect the lower extreme, that's our lowest value with the line, and the upper extreme, that's our highest value with the line. Okay? So if you want to remind yourself, this is Q1, this is lower extreme, Q1, median, Q3, upper extreme. Okay? Then when we're looking for the range that is the most clustered, remember it split this into 4 parts. We have part 1, part 2, part 3, and part 4 that are all 25% of the data, okay? So looking at where it's the most spread out, let's calculate the distance. You can either count 1, 2, or you can subtract. 67 minus 65 is 2. Right here you can count, it's a distance of 1, or subtract. 68 minus 67 is 1. Right here, 1, 2, or subtract. 70 minus 68 is 2. Right here, 1, 2, 3, 4, or subtract. 74 minus 70 is 4. So where is it the most clustered? So the smallest range, 2, 1, 2, 4. This range of 1 is the smallest. That was going from our Q1 to our median. Where is it the most spread out? 2, 1, 2, 4. 4 is that longest range there. That was going from our Q3 to our upper extreme. Okay, let's do one more and then off to the U try. The number of goals scored by Blackhawks players in 2012-2013 season is shown in the table below. So let's start off by putting in order from least to greatest. 3, 5, 5, 7, 7, 7, 9, 9, 10, 18, 23, and 23. Let's first find the median. Crossing off. Let's count actually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have an even number, so there should be 2 numbers in the middle. Lowest, highest, lowest, highest, lowest, highest, lowest, highest, lowest, highest. There's 2 numbers in the middle. Going to add them together, divide by 2. That tells me that the median is 8. Draw a line through the middle. The 7's going to be part of the bottom half. The 9's going to be part of the top half. If you want to count to double check, 1, 2, 3, 4, 5, 6 on the bottom, 1, 2, 3, 4, 5, 6 on the top. It's an even number, so there should be 2 numbers in the middle. Lowest, highest, lowest, highest. We're left with 2 numbers here. 5 plus 7 divided by 2 gives us a Q1 of 6. Same thing on the top. Lowest, highest, lowest, highest. 2 numbers in the middle here. Add them together. Divide by 2. And we get a Q3 of 14. Our lower extreme, our lowest number was 3. Our upper extreme, our highest number was 23. So, let's plot those points. 3, 6, 8, 14, 23. So again, the second and the fourth one, those are the sides of our box that we will connect. This dot in the middle is our median. Draw a line through it. Connect the lower extreme with a line. Connect the upper extreme with a line. What range is it the most clustered? Again, let's look at the parts that we're looking at. Part 1, part 2, part 3, part 4. This is our lower extreme, Q1, median, Q3, upper extreme. Let's calculate the distance for all of them. You can count 1, 2, 3, or subtract. 6 minus 3 is 3. Right here, 1, 2, or 8 minus 6 is 2. Right here, 1, 2, 3, 4, 5, 6, or 14 minus 8 is 6. And right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 23 minus 14 is 9. So the most clustered, the smallest range is 2. That was between your Q1 and your median. And the most spread out, the largest number that we have is 9, which was between our Q3 and our upper extreme. Go ahead and do the U-try.